Okay, here we go. We're recording. This is for the RC robotic motor control matrix. Now you take your switch. When you get it, the switch has a detent. The first thing we do is we take away that detent. We do that by bending the little spring clip downward in two places, here and here. And also this top locator tab, we bend that down as well, out of the way. We don't use that. Now the switch just rolls free. The next thing we do, we take the 20 gear and drill the center out. We do that incrementally in two or three different stages so we don't lose centering. And it has to fit snug. Don't drill the hole too big. This gear should fit snugly on the shafts. There you go. That's your switches ready to use. Okay, the next thing, you're going to make your switchboard. You're drilling two holes in a piece of plywood to mount your switches. And then underneath, you need to build the bottom of the board up with some extra wood here. So you'll have somewhere for your shafts to sit. Now, these pilot shafts are just drill bits. And they're drilled down and left in the board. So you'll position your gear, the 50 gear, until it meshes like that, drill down, and then you leave the drill bit in place, and that becomes your pilot shaft for the 50 gears. Now I'm using the center bushings in the big gear, and it just so happens that the size of this drill is also the same size as the servo horn holes, and you will use it later to drill the hole for your servo horns in the webbing on the big gear. So if you can see here, the switchboard, there's the both switches, the pilot shafts, and the big gears mounted. Here's basically a popsicle stick servo holder. There's 3 plies on each side. Give enough meat for the screws to hold. When you do that, you make sure the spacing on there is exactly the same distance as the centers here, so that they're in a straight line, and your servo horn should be at 90 degrees. Okay, and when you do all that, momentarily we'll link it all up and we'll get it going. The next thing I want to show here, if you can see, you take your terminal block, mark 6 popsicle sticks with the spacing of your terminal blocks. Then you'll take the LEDs and straddling the popsicle stick with the proper spacing, you put all the long leads to one side, anodes to one side, cathodes to the other. Then you'll take a little bit of glue on another stick like this, and we're going to sandwich that down, just like so. And then one more on the other side. So the diodes are then sandwiched in between 3 popsicle sticks and glued in place. Now, it's a little bit funny to do here, and then you take some spring clamps, clamp it all together and let it dry. And once you got your clamps on, just make sure you got your proper spacing and you're happy with it. You can set it aside to dry. Okay, that looks good. Here's one already made using clear LEDs. It's a common cathode for one, common anode for the other. And they're color coded. I'll explain that in the text. Next you want to do your diodes. Now for the diodes, you're going to put a thin little bit of glue down to tack them in, and you'll make 2 of each. One with the cathodes down towards the board and 2 with the cathodes up. So you need 4 of these. You'll have 2 common anodes and 2 common cathodes. And I'll run you through this. This one, just put a little wee bit of glue, just enough to hold the diodes. I hope you can see that. I got the right angle, and you'll position the diodes. This one I'm doing, the cathodes will all go down towards the stick. I'll show you, here's a completed one. Now we have on one side cathodes up, that's the positive drive rail. On the other side, cathodes down, that's your negative drive rail. Then on top, there'll be a junction from each of the pairs. These are your motor drive rails. You need 2 of those. to drive 24 motors in forward and reverse, and 2 banks of 12. So we'll continue on here, laying our diodes into the glue. It's the same procedure. Then we're going to sandwich it down with 1 more stick on top. Like I say, you make 2 of each. 2 with the cathodes down, 2 with the cathodes up. If you follow these directions, you cannot go wrong. It's foolproof. In the system, this will simplify construction immensely for beginners, or you don't need a circuit board. There will be 1 small circuit board. This is it here. It has 2 inversion relays, and we use this to take a positive trigger from the matrix and then switch a negative voltage to the negative drive rails for the motor reversing. We require only 2 relays, one for each motor drive bank. So each relay reverses 12 motors, and those motors are referenced to the common ground axes. This is a really good system. Now take another little bit of glue on another stick, press it down on top. So you've sandwiched your diodes into the glue. What you want to do is get your clamps on and then fool around with the thing. Once you've got a couple clamps, and then position everything nicely so the spacing's right and they're all standing straight. Do the best you can. And I'm going to take 1 screw clamp here. We're going to put 1 screw clamp in the middle. It would help if you had an extra set of hands. You do what you can. Okay, again, I just want to make sure everything's nice and straight here. I say it's a little bit of a conundrum. Have patience, and it will work out for you. There, I'm fairly happy with that. Now we'll set that aside to dry. You need to make 4 of these. 2 with the cathodes up, 2 with the cathodes down. Okay, we'll set that aside. I'm almost ready to actually assemble this one and start. Here's one I'm just working on. Okay, we got our 1 rail in already. The switchboard's made. Here's another look at the switchboard. You see how it's built up on the back to accept the drill bits, which then become your pilot shaft for the big gear. Here's my popsicle stick servo tray. There's 3 layers thick here of popsicle sticks, so we got some meat for the screws to grab onto. And we're just about ready here to do the final assembly, but I will step you through this again step by step. Not to worry, I won't leave you hanging. I'm going to also, at the end of all of this, when your matrix is working, I'll begin to show how to build robotics and how to make axles and different things out of old drill motors and anything you can find. It's all good stuff. So I hope that gives you enough, a little bit of information to get started. Once again, we remove the detent from the switches, bend the tab back, drill the 20 gear to fit snugly to the switch spline, mount the switches to your switchboard. If you're going to use popsicle sticks for your matrix, you got to make sure that your spacing here is such that you can get your servos in position and still be able to couple to the outside. So the distance there for me is 2 3/4 inches between the 50 gear pilot axles, and that will allow you to build a popsicle stick servo tray. Also, this whole box here is made from tangerine box wood. It's all tangerine boxes and popsicle sticks. And this stuff's really easy to cut. Bear with me for a sec. You can cut this plywood real easy by just scribing with a knife similar to this. Once you got your line and you just keep cutting, it's so easy to cut and work with. A kid could do this. Thank you. I'll be doing some more videos shortly. That will be it for this one. Thank you.